So let's talk about this rate of change. Now, rate of change is just a fancy word for slope. It's not all that fancy anyway. But rate of change is what we normally call it in applications. Like how fast is our y variable changing for every change in x. So how fast is y changing for each change in x? And that's really what we're talking about. And that's why we're talking about that. It's a rate of change. And in our case, if we have a linear function, then the rate of change is constant. It's always going up. Now, the difference between that, I want you to think about it. Here, the rate of change is constant. Anywhere I do this, the slope's going to be the same. But what if I have something like this? There, the rate of change isn't constant because here, this rate of change is very little. But here, it's very large. So this one does not have a constant rate of change. This does have a constant rate of change. So what we're going to restrict ourselves to in this class is constant rate of change. Those of you who are moving on to 221 after this will start studying the non-constant rate of change, and that's essentially calculus. So to illustrate this, in one of the ways that we're going to be talking about it a lot is revenue, cost, and profit. So just really quick, the revenue is usually the price times X. Okay. The cost is often unit cost, call that little c, times X, plus a fixed cost. Okay, so, and profit is revenue minus cost. I'm getting crazy on my writing here. Okay, yeah, we'll stay where I want it. Okay, so a company produces and sells bottle openers. They sell each bottle opener for $10. Okay, we can easily now find the revenue function. The price is $10 and they sell X. So if they sell X bottle openers, their revenue is going to be 10X. Then the cost to make each opener is $2.50, but they have an overhead fixed cost equaling $1,250. So that means that the cost is 2.5X plus $12.50. And so now the profit function is going to be your revenue minus your cost. Now you make sure you put your cost function in parentheses, because if you do not, you're going to forget that this needs to be subtracted from profit, because that's your fixed cost. You have to make sure that is subtracted from profit, and I can't say that enough times. So 10X minus 2.5X minus 1250, because remember, your fixed costs are coming out of your profits, not being added to them. So this means that your profit is 7.5X minus 1250. So let me look at this for a second. So if we want to look at these on a calculator, okay, we've got on this one 10X, and then we'll do all these. There we go. 2.5X plus 1250. And those of you who have a color one, this would be so much nicer for you. And here we have 7.5X minus 1250, because that's coming out of our profit. Okay, so let's graph. But before I graph this, I want you guys to think about it for just a second. What kind of window do I need here? What you guys think? Do I need to go, does X need to go below 0? No, not really, right? X does not need to go below 0. But how far does X need to go? How far should X go? Well, we can think about what the intercept would be. What's the X intercept on this one would be 0, right? Because it's 0, 0 is a point. The X intercept on this one, let's see, 1250 divided by 2.5. Well, let's see. 1250 divided by 25 would be 50. So that's going to be like 500. And then this one down here is going to be a little bit, oh, it's going to be negative. So it doesn't even matter where X is there because that's going to be negative. And then down here, divided by, so probably I'm going to guess about, let's do 300 to be safe. I don't think we need much more than that. See, we can estimate. We really don't have to think about this completely. Because, let's see, I have 1250 divided by 7.5. So this was, what did I say, 500. So this is going to be about a third of that. That's probably a little more than we need. And then we want our Y max. We want to make sure we go over 1250 for the cost function. So let's just do 2000 or 2, yeah. And let's see here. Okay, let's graph it now. And this is going to be all 3 of them. So there's our revenue function, there's our cost function, and there's our profit function. Okay. Everything is increasing. Do you notice this? As we make more product, all 3 of these should be increasing. So if we look at this one, if we look at this first line, this line right here, that's my revenue function. And it just starts at 0, 0, and then just shoots up. Okay. Then we look at our cost function. Here's our cost function. This is C of X. This is what it's costing to do this. Not too much. The slope is fairly small, right? And then this is our profit function. And we don't start making a profit until we make this many, which, look, that's the same place as the intersection between those two. It's the first time we start making a profit, because here cost is more than profit, or cost is more than revenue. It isn't until we get this many that revenue is more than cost. So we start actually making a positive profit right at that point. Okay. Let's put that down for a minute. So let's talk a little bit about what marginal revenue and marginal cost, marginal profit, and all of this stuff means. So marginal revenue, oops, is equal to the rate of change of the revenue function. And for our purposes, usually for linear revenue functions, this is usually price. So, but later on, when you guys start going into other things in calculus, you will see revenue functions that are not linear functions, because you have to have an idea of demand in there also. Because sometimes you can't just set your price at $10 and be done with it. Your prices change constantly because of supply and demand. And then you have marginal cost. This is the rate of change of the cost function. And again, for linear cost functions, this is unit cost. And finally, marginal profit is the rate of change of the profit function. So this is how much profit is made, how much more profit is made by producing and selling one more item. So right now we have constant marginal profits. So let's look at our marginal revenue for our example. Well, remember our revenue function was 10x. What's the slope of that line? 10. So this means for each item we sell, we make $10 more. So marginal cost, remember our cost function was 2.5x plus 1250 was 2.5. So this was for each item produced, cost increases by $2.5 or $2.50. Marginal profit was 7.5. Remember our profit function was 7.5x minus 1250. So 7.5 for each item produced and sold, profit increases by $7.50. So that gives you an idea of marginal profit. Now, one thing I did want to show you that we could, for profit, cost and revenue can't be below zero. But let's say that I was just wanting to look at the profit function. When I look at window, and this is something important I want to talk about, you can actually have your Y-min go below zero because you can make negative profit. So I can make this down to negative 2,000 because I can be losing money. So when I graph it now, we can see more of the profit function. And you can see this part of the profit function that's below zero. This is where you're losing money. And here you're making money. So just something I wanted to show you, that you can have a revenue function. You can have the Y below zero. You can't have the X below zero, but you can have the Y below zero. Okay, so that's it for that recording, and we'll do some more interesting examples and things like that in class.